Good evening, all of you. In the previous sessions, we completed our discussion related to Docker. What is Docker? What is containerization? How to work with Docker images, Docker containers, Docker network, Docker volumes, Docker compose, Docker swarm. Like that, we completed our discussion related to Docker. Now, we are going to start with another tool in the DevOps tool chain, that is Kubernetes. This Kubernetes tool is the most important tool in the DevOps course. Every DevOps engineer should know about this Kubernetes. If you attend 10 interviews on the DevOps, in 10 interviews, they will ask questions related to Kubernetes. So that much important it is. And this is the last most important tool that we are going to discuss in our DevOps course. This week, we are going to spend completely for this Kubernetes. Once Kubernetes is completed, small tools are available like Prometheus, Grafana, ELK, all those tools we can complete within 2 days of time. That's not big deal. The most important tool now we are going to start, that is Kubernetes. And before going to start the Kubernetes, I'm going to tell you setting up the Kubernetes, understanding the Kubernetes, working with the Kubernetes is a little difficult when we compare it with other tools. We discussed several tools in our course like Maven, GitHub, Jenkins, Ansible, Terraform, Docker, Tomcat, right? Several tools we discussed. When compared with all those tools, Kubernetes is difficult, little difficult. You need to focus more. Lot of commands we need to execute in the Kubernetes. We need to have a lot of concentration to understand this Kubernetes concept, Kubernetes terminology, Kubernetes commands, working process with the Kubernetes. It is little difficult. Okay, even in the industry, the people who are working on the DevOps and Java and these technologies, most of the people are not aware of this Kubernetes. Most of the people will feel Kubernetes is difficult. That's true. It is difficult, but we need to learn that concept. Without having the Kubernetes knowledge, you cannot get the job as a DevOps engineer. It is a damn important tool for our DevOps practices. Okay, so this 1 week we are going to spend to understand Kubernetes. So please focus and concentrate. Don't miss the live classes, and whatever we discussed every day you need to practice, then only you will get the clarity on the Kubernetes. All right, let's get started. Are you guys okay? Shall we get started with Kubernetes? Can we get started with Kubernetes? Come on, please give the confirmation, guys. Are you ready? Good. Kubernetes. Guys, some people will call this Kubernetes as K8s. Some people will call this Kubernetes as K8s. The reason for calling K8s is between the K and the S, there are 8 characters are available. So when I am going to call this, sometimes I may call it as Kubernetes, sometimes I may call it as K8s. What is the meaning of this K8s? In between the character K, first character K and last character S, there are 8 characters available. You can count them. That's the reason people will call it as K8s. That is called Kubernetes. Good. What is this Kubernetes? First thing is Kubernetes is an orchestration engine. K8s is an orchestration engine. We already discussed what is orchestration. Orchestration is used to manage containers. Orchestration is used to manage containers. We are going to create several containers for our application. Docker containers we are going to create. Creating the containers, starting the containers, running the applications, stopping the containers, deploying the latest changes in the container. Doing all these things manually is a difficult process. So we need some automation to manage our containers, to scale up our containers, to scale down our containers. For that, we are going for orchestration engines. Docker Swarm, we have seen already, Docker Swarm is one of the orchestration platform. And advanced to the Docker Swarm, we have Kubernetes. Kubernetes is also used for orchestration purpose. Kubernetes is an orchestration engine. Kubernetes is an open source platform or open source software. We can say that it is OSS software, open source software. You no need to pay any money to use this Kubernetes. It is free software. Kubernetes is used to manage containers, or is used to manage containerization based applications, or containers of our application. It is an orchestration engine. It is open source software. It is used to manage containers of our application. Kubernetes will take care of containers deployment, scaling, descaling, and load balancing, containers load balancing. So completely it is going to manage containers of our application. That's why we are calling it as orchestration platform. Docker is just a containerization platform. Kubernetes is orchestration platform, right? Orchestration means managing the processes. Kubernetes is going to manage Docker containers. Kubernetes is not replacement for Docker. Docker purpose is different. Kubernetes purpose is different. Docker is used to manage the application as a container. Those containers will be managed by Kubernetes. We can say that Kubernetes is an orchestration platform. Kubernetes is replacement for Docker Swarm. It is not the replacement for the Docker, but we can say Kubernetes is replacement for Docker Swarm. Kubernetes developed by Google. Kubernetes developed by which company? Developed by Google. Developed by Google and donated to CNCF, Computer Native Cloud Native Computing Foundation, in 2014. This Kubernetes software developed by Google company in the year of 2014, and that Google company donated this software to CNCF. So CNCF means cloud. CNCF means Cloud Native Computing Foundation. It is one organization. Cloud Native Computing Foundation. Google developed this Kubernetes in the 2014 and donated to CNCF Foundation. Kubernetes software developed by using Go language like Java, Python. Go is one programming language. That Go language also developed by Google. Using that Go language, Google company developed this Kubernetes software. Kubernetes first version in the 2014, the software got developed by Google. Then Google donated this software to CNCF company. Then that CNCF company released Kubernetes first version to the market in the year of 2015, July 21st. Kubernetes version 1.0 released to market in the year of 2015. From 2015 onwards, Kubernetes software available in the market as an open source software. People started using the Kubernetes to manage containers of our application. Containers we are creating by using Docker. Container will take care of application code execution with application dependencies. The complete platform which is required for the application will be taken care by Docker. So our application is based on the microservices. So for every API in our project, one container will be created and some database containers, some cache containers will be available. Managing all the containers manually is a difficult process. So that's why we need one orchestration platform to manage our containers. Managing the containers nothing but deploying the containers to the servers, scaling our containers, scale up, scale down, load balancing for our containers. All these things comes under management of the containers. So any software which is managing our containers, that is called as orchestration software. Docker Swarm is one of the orchestration software, but in the Docker Swarm, production ready features are not available. So that's why people are going for Kubernetes. So theoretically, are you clear what is Kubernetes? Kubernetes is an orchestration engine. Kubernetes is an open source software. Kubernetes is used to manage containers of our application. Kubernetes will take care of container deployment, container scaling, container descaling, and containers load balancing as well. Kubernetes is not replacement for Docker. Kubernetes is replacement for Docker Swarm. Kubernetes developed by Google and donated to CNCF organization in the 2014. CNCF means Cloud Native Computing Foundation. This Kubernetes software developed by using Go language in the Google company. Kubernetes first version released into market in the year of 2015. Clear? Now, here you may ask, sir, what are the benefits of going for Kubernetes? There are several advantages are there. Before going to see the advantages, let's understand what are the differences between Docker Swarm and Kubernetes. As we told, as we discussed already, Docker Swarm is also one orchestration platform. Kubernetes is also one orchestration platform. Then what are the differences between Kubernetes and the Docker Swarm? In the Docker Swarm, you can scale your containers, but manually you need to scale. How many containers you want to run? Those number you need to give manually. So you need to scale manually how many containers you want to create for your application. Auto scaling concept is not available in the Docker Swarm. But whereas when we go for Kubernetes, auto scaling support is available. So based on the traffic, it can identify how many containers required. It is going to create those containers and it is going to manage those containers. So scaling the containers is a manual process in the Docker Swarm, whereas in the Kubernetes, it is auto scaling concept. For the Docker Swarm, good community support is available. If you face any issue, that community support will be available for Docker Swarm, but for Kubernetes, great active community is available. Here in the Docker Swarm, good support is there, but in the Kubernetes, great support is available. In the Swarm, cluster setup is easy. In the previous classes, we have seen how to set up a cluster in the Docker. One master node I have taken, two worker nodes I have taken. Setting the cluster is very easy in the Docker Swarm, but it is difficult in the Kubernetes. The installation of the Kubernetes, setting up the cluster of the Kubernetes is a difficult process. Lot of commands we need, almost 50 plus commands we need to execute to set up this Kubernetes cluster with all the required things. Okay, now this Docker having limited to Docker API capabilities can overcome the constraints of the Docker and Docker API. So Docker Swarm is going to limit the functionalities or capabilities up to only Docker API. Whatever is missing in the Docker API, those things we are going to get in the Kubernetes. Now, this Docker Swarm does not have much experience with the production deployments at the scaling. So Docker Swarm is not recommended for production deployments of our application because manual scaling, everything we need to manage on our own. Whereas in the Kubernetes, auto scaling concept is available, load balancing concept is available. So this is best suitable for production deployments of our application. So if anybody asks what are the differences between Docker Swarm and Kubernetes, then we need to explain this. In the Docker Swarm, scaling is manual process. In the Kubernetes, scaling is automatic process. For the Docker Swarm, good community support is there, but for Kubernetes, great support is available. But cluster setup is easy in the Swarm, but setup is difficult in the Kubernetes. More features are there in the Kubernetes, setup is little difficult. Okay, so Docker Swarm is limited to whatever the facility is there in the Docker, same thing we can achieve, limited to Docker capabilities. Whereas in the Kubernetes, it can overcome constraints of the Docker and the Docker APIs. Docker Swarm is not suitable for the productions because of manual works that are required to set up everything. Kubernetes deployed at scale more often among the organizations. Most of the organizations nowadays for production deployments, Kubernetes only they are using for orchestration platform. Are you guys clear with the differences between Docker Swarm and Kubernetes? Good. Now tell me which one is recommended to manage the containers in our application? Docker Swarm or Kubernetes? Kubernetes is recommended. What is Kubernetes? It is orchestration platform developed by Google. It is going to manage containers of our application. The first version of the Kubernetes released in the 2015. Kubernetes official website is also available. Kubernetes official website is also available. We can go through that. Kubernetes. Okay, Kubernetes.io, the official website is available. Production grade container orchestration. Kubernetes is an production grade container orchestration platform. To give the official definition for the Kubernetes, we need to say Kubernetes is an production grade container orchestration platform. Production grade, nothing but the containers which are ready to deploy in the production can be managed by using Kubernetes. Kubernetes is also known as K8s, is an open source system for automating deployment, scaling, and management of containerized applications. Okay, planet scale, never outgrow, run K8s anywhere. You can run the Kubernetes anywhere. Okay, so all these things are available. Kubernetes features are available. You see what are the features available in the Kubernetes? Automated rollouts and rollbacks, service discovery and load balancing is available, storage orchestration available, secret configuration management is available, automatic bin packing is available, batch processing available, dual stack IP address support is available, horizontal scaling available, self-healing capacity is available, designed for extensibility. These all are the features of going for Kubernetes. These are not my statements. These are the points given by official website of the Kubernetes. Got it. So what are the Kubernetes features that you can see in the official website of the Kubernetes? Kubernetes features. Kubernetes features. So what are the features available when we go for Kubernetes platform? There are several features available in the Kubernetes. The first one is automated scheduling. The first feature is automated scheduling. Second one, self-healing capabilities are available. Self-healing capabilities available in the Kubernetes. Automated rollouts, rollbacks available. Automated rollouts and rollbacks available. Load balancing is available. Horizontal scaling and load balancing is available in the Kubernetes. Service discovery is available. Service discovery is available. Storage orchestration is available. Storage orchestration is available. These are the advantages of going for Kubernetes. These are the advantages of going for Kubernetes. So what is automated scaling? So they mentioned clearly what is that automated scaling. Okay, automated scaling is available whenever automated rollouts, rollbacks available, load balance, automated bin packing, self-healing, horizontal scaling. Scale your application up and down with a simple command with your UI or automatically based on CPU usage. Scale your application up and down. Scale your application up and down with a simple command. So I want to increase the capacity of my infrastructure, or I want to decrease the capacity of my infrastructure. By using a single command, you can do that, or they will provide you one user interface also to scale up and scale down your applications. Okay. Now, Kubernetes is providing advanced scheduler to schedule our application deployments. Kubernetes providing advanced scheduler concept, advanced scheduler concept. Automated scheduling concept is available. It is providing advanced scheduler concept to launch our containers. So I want to launch my container today at 11 p.m. that you can schedule. You can schedule. Kubernetes providing advanced scheduler concept to launch containers depends on our requirement. Depends on our requirements. Got my point? Okay. Next one is self-healing capacities are available. Self-healing capacity is nothing but whenever one node got down, then it is going to take care of that failure and it is going to schedule another container to handle that load. Restart containers that fail, replaces and reschedule containers when nodes die, kills containers that do not respond to your user-defined health check and does not advertise them to clients until they are ready to serve. So this is a self-healing capacity feature. The what Kubernetes is telling, restart containers that fail. Suppose if any container is failed, then Kubernetes is having self-healing capability. So if a container is failed, it is going to restart that container, replaces and reschedules a container when nodes are going to die. Suppose any particular node went down that due to some power failure, due to some memory issue, due to some network issue, due to n number of issues. Suppose for example, your node got down, then Kubernetes is going to kill that node which is not responding to the health check. So we are going to configure user defined health check. If the node is not responding to the health check, Kubernetes is going to kill that node and it is not going to advertise that node to the clients until they are ready to the serve. If you create 4-node cluster, if one of the node is not responding, then Kubernetes is going to kill that node. If any container is failing, Kubernetes is going to restart that container. That the self-healing capabilities are available for Kubernetes cluster. Advanced scheduler is available with the Kubernetes where you can schedule your containers deployments. Self-healing capabilities are available. Okay. Automatic rollouts and rollbacks concept is available. For example, I want to deploy some code. Now I have deployed some code, but my code went wrong. The functionality not working. I have done some changes to the code. I have deployed that functionality to the production. That code is not working as expected. Kubernetes progressively rolls out changes to your application or its configuration while monitoring application health to ensure it does not kill all your instances at the same time. If something goes wrong, Kubernetes will roll back the changes for you, take advantage of growing ecosystems of deployment solutions. So if anything went wrong in your code, if something goes wrong, Kubernetes will roll back the change for you, take advantage of a growing ecosystem of deployment solutions. I have done some changes to my configuration. I push it to production, but I have deployed some code. I have made some changes to my code. I made some changes to my code. That change is not working as expected. I want to roll back my change. Kubernetes can do that automated rollbacks for you based on your requirement. Kubernetes can roll back that change based on your requirement. Automated rollbacks can be done by using Kubernetes. And load balancing. Kubernetes can scale up and scale down your application with a simple command or with a simple UI or automatically based on CPU usage. That load balancing we can do. Load balancing is a manual process in the Docker Swarm, whereas load balancing is auto scaled in the Kubernetes. Okay. Note, in Docker Swarm, load balancing is a manual process. Load balancing is manual process, whereas Kubernetes supports auto scaling. Okay. So if you go for a Docker Swarm, if you need to do the load balancing manually based on your requirement, whereas Kubernetes is going to do that automation for you. Auto scaling concept is provided by Kubernetes. Okay. Next one, service discovery. What is the meaning of service discovery? How many nodes are running? What is the network communication we need to create among those containers, among those nodes? That network related communications will be taken care by Kubernetes cluster. You no need to bother about this. With the Kubernetes, we no need to worry about the networking and communication, because Kubernetes is going to assign one IP address for every node, and it is going to take care of that network related communications among the cluster related nodes. With Kubernetes, we no need to worry about the networking and networking related concepts. Okay, see here, service discovery concept is available. No need to modify your application to use an unfamiliar service discovery mechanism. Kubernetes gives pods their own IP addresses and a single DNS name for a set of pods and can load balance across them. No need to modify your application configuration. You no need to manage the network related communications, because Kubernetes gives pods their own IP. What is pod? That we are going to discuss, right? Kubernetes gives pods their own IP addresses and a single DNS name for a set of pods and can load balance across them. That service discovery mechanism is available. We no need to bother about networking and communications. No need to modify your application to use an unfamiliar service discovery mechanism. Kubernetes will give a IP address and a single DNS for everything, and it is going to manage that. Storage orchestration. Automatically mount the storage system of your choice, whether from local storage or public storages. Now, in the Docker, we used a concept called volumes. Docker volumes concept we have used. What is the purpose of Docker volumes? For storage purpose. When the container is running, some data will be generated by the container. When we stop that container, we are going to lose that data. So we need to mount that container data to a volume, or we need to mount that data to a directory. So that is called storage orchestration. When we go for the Kubernetes, automatically you can mount the storage system of your choice, whether from a local storage or public cloud provider such as GCP or AWS, or a network storage system such as NFS or Gluster, SEP, Cinder or Flocker. So you can do that storage. Whatever the data that is generating by the Kubernetes cluster, you can store into your local system, or you can store into a cloud platform also. Storage orchestration also, it is going to take care. Okay, secrets and configuration management. Whatever the configuration we are writing, that port numbers or usernames or passwords, you no need to configure them for public read access. You can secure your configuration files by using secret configuration management, which is providing by Kubernetes. Deploy and update secret and application configuration without rebuilding your image and without exposing secrets in your stack configuration. Whatever the configurations we are doing, we can configure them securely by using Kubernetes secret configuration management. Okay, guys. Batch execution. In addition to the services, Kubernetes can manage your batch and CI workloads, replacing containers that fail if required. Batch execution process that is going to do. Add features to your Kubernetes cluster without changing upstream source code. Self-healing capacity. Allocation of IPv4, IPv6 addresses to pods and services. It supports two types of IP addresses, IPv4 and IPv6 addresses. All right. So these all are the features of going for Kubernetes. So high level, automated scheduling. So you can schedule your application deployment by using advanced scheduler provided by Kubernetes. If any particular container is failed, Kubernetes is going to restart that container. If any node is dead, then Kubernetes is going to kill that node and it is going to replace that. Okay. If the node is not working properly, Kubernetes will not use it for processing the requests. Automated rollouts and rollbacks can be done by using Kubernetes. If you make any change in the configuration and push it to production, it is not working, then we can roll back that configuration by using Kubernetes. We can scale up and scale down our application containers based on the demand. This scale up and scale down is automated in the Kubernetes. In the Docker Swarm, we need to do this manually, whereas in the Kubernetes, auto scaling concept is available. Service discovery. So the network related communications will be managed by Kubernetes cluster. It is going to provide one IP address and it is going to provide a single DNS for all the pods which are running in the Kubernetes cluster. Right? Service discovery also will be taken care by Kubernetes. Storage orchestration. When the containers are running, they are going to generate the data. That data is going to be removed when we stop that container. So we need some storage mechanism. Kubernetes providing that storage mechanism for our containers. You can store that data for your local storage, or you can store it to cloud platforms like AWS, GCP, Azure also. Storage orchestration also, it is going to take care. Secret and configuration management. Any configuration files that you are creating, you can keep it securely by using secret configuration management provided by Kubernetes. Lot of advantages are there. Do we have these many facilities in the Docker Swarm? Do we have these many facilities in the Docker Swarm? Guys, are you understanding what is Kubernetes and what are the advantages of going for Kubernetes? Are you understanding what is Kubernetes and what is the purpose of going for Kubernetes? Kubernetes is an orchestration platform which is used to manage containers of our application, developed by Google, released to market in the year of 2015. There are so many advantages are there. That is the reason in the industry, Kubernetes is having this much demand. In every interview, they are going to ask the questions on the Kubernetes. So do you have any experience in the Kubernetes? Can you tell me how to set up the Kubernetes cluster? Can you tell me how you will do the load balancing of our application by using Kubernetes? Can you tell me what is pod in the Kubernetes? Can you tell me what is the namespace in the Kubernetes? Can you tell me Helm charts in the Kubernetes? Can you tell me secret configuration management in the Kubernetes? Can you tell me what are the concepts you are using in the Kubernetes for your application? All these things are important. In every interview, they are going to ask the questions on the Kubernetes. Anybody attended interview? Did anybody completed your interview without asking questions on the Kubernetes as a DevOps engineer? If you attend a DevOps interview, any interview completed without questions from Kubernetes? Some people are attending the interviews, right? Any interview completed without questions on the Kubernetes? If they conduct an interview without questions asking on the Kubernetes, that means the person also don't know Kubernetes, who is taking that interview. Then only he will not ask. Otherwise, in every interview, they are going to ask the questions on the Kubernetes software. That damn important it is, and it is difficult also. It is not that much easy. It is not that much easy. Okay, good. So with this, are you clear with what is Kubernetes and why Kubernetes? Are you clear with this? What is Kubernetes and why Kubernetes? Are you getting? Are you guys getting my point? As of now, easy? As of now, easy or difficult? As of now, easy. Theoretically, what is Kubernetes? What are the features of the Kubernetes? The most important thing that we need to know, Kubernetes architecture. If you understand the architecture, then only you can start working with Kubernetes. Kubernetes architecture. This is also an important question. What is Kubernetes architecture? We have seen Docker architecture, right? Docker will have a Docker file. From the Docker file, we are going to create a Docker image. Docker image will store to Docker Hub. We will pull the Docker image and we will run the Docker image. Then container is going to create. Okay. Kubernetes architecture. Kubernetes follows cluster architecture. Okay. Kubernetes implements a cluster computing background. Everything works inside a Kubernetes cluster. Kubernetes works as a cluster. Kubernetes software is going to work as a cluster. In this Kubernetes cluster, we will have master nodes and worker nodes. In Kubernetes cluster, we will have master nodes. We will have master nodes and worker nodes. We will have master nodes and worker nodes. Okay, master node is nothing but which is going to schedule the deployments, which is going to assign the task to the worker nodes. Worker nodes are going to the actual machines where our containers are going to execute. Okay, so when we are talking about Kubernetes architecture, we need to know about master node. We need to know about master node. We need to know about worker node, and we need to know about API server, API server, API server, then controller manager, and etcd. There is a concept called etcd, and we are going to have another world there. This is pods will be available in the Kubernetes. Pods will be available in the Kubernetes. Containers will be available in the Kubernetes. The containers of our Docker containers will be available. Docker containers will be available. Then Docker will be used here. Docker containers will be used here. Docker containers will be used to run our application. Docker is a runtime environment for the Kubernetes cluster. Kubelet will be available. Kubelet will be available. Kubelet will be available, and kube proxy will be available. Kube proxy will be available, and kubectl will be available. Kubectl will be available. Kubectl will be available. So the C, to understand all these things, we need to have lot of concentration, guys. See here, the architecture itself is lengthy. There are so many components involved in the Kubernetes architecture. Kubernetes is going to work as a cluster on cluster model. Kubernetes works on cluster model. Right? When we talk about a cluster, master nodes will be available, worker nodes will be available. Master node is going to work as a manager, worker node is going to work as a employee. Master node will assign the work to worker node. Worker nodes are going to complete that work. Okay, so here, in order to understand this Kubernetes architecture, you need to have the knowledge on these components: master node, worker node, API server, controller manager, etcd, pods, containers, Docker runtime, kubelet, kube proxy, kubectl, kubectl, minikube, like that. There are some other platforms also available. We'll come to that. So this is the, when we are talking about Kubernetes cluster, from today to next 1 week, we are going to use this terminology in our class. Every day I'm going to use this terminology in our class. So first understand the terminology, then we can set up Kubernetes cluster in our machines. Okay, before going to talk about these topics one by one, let me show you architecture diagram. Can you guys see this Kubernetes architecture diagram? Can you guys see this Kubernetes architecture diagram? Whatever I have noted down, can you see everything here? Whatever I have noted down, can you see everything here in the diagram? Control plane. Control plane. Control plane is nothing but our master node. Control plane is nothing but our master node. Worker node are available. So this is a cluster. Control plane is called as a master node. That master node will manage worker nodes. In the worker nodes, Docker is available. Docker is a runtime environment to run the containers. So to run a Docker container, Docker runtime is required. So worker node will have a Docker runtime. On this Docker runtime, we are going to run Docker containers. Docker containers will be grouped as one pod. Pods will be available. Kubelet will be available. Kube proxy will be available. So on the worker node, kubelet, kube proxy, Docker, containers, pods will be available. That's why when I am writing, I have given some space. You see here, I have written like this, and I have given some space between 5th point and 6th point. The reason, this terminology related to worker node, this terminology related to master node, and this is kubectl, it is a different concept. Are you guys clear with this? This is master node terminology, and this is worker node terminology. This is interaction part. kubectl is used to interact with the master node. Okay, master node is also called as control plane. So here master node is also called as control plane, which is used to control the Kubernetes cluster, which is used to control worker nodes of our Kubernetes cluster. So right, in the control plane, or I can say master node, what are available? API server available, and one thing I have missed here, scheduler. There is a concept called scheduler is available, and controller manager is available, and etcd available. Coming to worker node, pods available, containers available, Docker runtime available, kubelet available, kube proxy available, and finally kubectl is also available. kubectl and UI part. kubectl and UI part is available. Now, so look at this diagram. Control plane is nothing but a master node. Kubernetes cluster. Kubernetes software is going to work based on cluster model. Master node will be available. Worker nodes will be available. Master node contains API server, scheduler, controller manager, etcd. Worker node contains pods. Inside the pods, containers will be available. To run the containers, Docker runtime will be available, and kubelet will be available. Kube proxy will be available. In the worker node, we can have more than one worker node also. Right. Then how to manage this Kubernetes cluster? Master node will be available. Worker nodes will be available. How to manage this Kubernetes cluster? You can manage the Kubernetes cluster in two ways. By using CLI also, you can manage. So if you want to manage, I want to start the containers, I want to schedule the containers, I want to roll back the changes, I want to do scale up, I want to do scale down. So those things, that Kubernetes cluster operations we can perform through CLI, that is called kubectl. kubectl is a CLI software which is used to execute Kubernetes commands. If you don't like that CLI approach, Kubernetes is providing a UI also to manage that cluster. Through user interface, you can control the master node, or through kubectl, you can control the master node. Are you able to understand what is a kubectl? Guys, are you able to understand what is a kubectl? kubectl is a CLI software. kubectl is a CLI software which is used to manage master node of our Kubernetes. If you don't like that CLI, you can go for user interface also to manage our Kubernetes master node. In the master node, we have API server, we have a scheduler, we have controller manager, we have etcd. We will talk about all these things. Sir, what is API server? What is a scheduler? What is a controller manager? What is etcd? We will talk about that. We'll talk about that. Next one, if you see the master node, API server, scheduler, control manager, etcd available. So you can operate this master node through user interface or through kubectl. Okay, mostly people will prefer this kubectl. Right, coming to worker nodes, what are the things available in the worker node, guys? Can you see? Kubelet available, kube proxy available, docker available, docker containers available, and pods also available. By looking at the diagram, you can understand what is a pod. Pod is nothing but collection of containers. Pod is nothing but collection of containers. Okay. Take the screenshot of this diagram. Daily we need to see this diagram. Then only we can work with Kubernetes cluster. Daily we need to see this diagram. So take a screenshot of this diagram. A beautiful diagram. You see, by looking at the architecture, you can understand a lot of internals we need to know. A lot of depth is there in the Kubernetes. That's why people will feel it is difficult. That's why people will feel it is difficult. Lot of depth is there in the Kubernetes, guys. Okay. Right. Now let's understand these Kubernetes architecture components one by one. What is that? What is that kubectl and what is that UI? So here kubectl, first of all, to communicate with Kubernetes cluster, we have two options. One is through UI, second one is kubectl, right? Kubectl, this is CLI software. To communicate with the Kubernetes cluster, we have two options. What are those two options? One is through user interface. Second one is kubectl. Kubectl is CLI software. Okay. Now, next one. What is a master node? Master node is going to manage the worker nodes and will assign the task to worker nodes. Master node manages worker nodes in the cluster. Marker node manages worker nodes in the cluster. It will assign tasks to worker nodes for execution. Worker nodes will run the tasks which are assigned by master node. Master node manages worker nodes in the cluster. Master node will assign tasks to worker nodes for execution. Worker nodes will run the tasks which are assigned by master node. Okay, master node is available. Multiple worker nodes are available. One master node can manage multiple worker nodes also. Actual execution is going to happen on the worker nodes. Who will assign the task to the worker node? The task will be given by master node. How can we operate the master node? To operate the master node, we have kubectl, that is a CLI software, and we have user interface also. Good. Next one. What is this API server? What is this API server in this master node? What is API server? In the control plane or in the master node, we can see API server. So what is this API server? What is the responsibility of the API server? In Kubernetes cluster, we have so many components, or we can say so many objects. In Kubernetes cluster, we have several objects, or we can say several services or objects. What are those? Pods available in the Kubernetes, which is used to run the containers. Replication controllers are available. Replication set concept is available. Daemon daemon set is available. Deployment concept available. Okay. Volumes concept is available. Persistent volumes available. Services available. All these services implemented using Go language. All the above Kubernetes services implemented using Go language. Now, in order to work with all these things, do we need to learn the Go language? Do we need to learn the Go language to work with all these objects or services provided by Kubernetes cluster? Kubernetes provided a concept called pods. Kubernetes provided a concept called replication. Kubernetes provided a concept called deployment. Kubernetes provided a concept called value, services, and all. In order to deploy my application on the Kubernetes cluster, do I need to learn Go language? No. You no need to know what is the code available in the Kubernetes. You just need to use the components. For example, if you want to deploy your application, there will be one command, kubectl deploy. Then your application is going to deploy. So how you are going to communicate with the Kubernetes cluster? Through API. Kubernetes provided one API server for you. You no need to manage, you no need to know what is the code available in the Kubernetes. Whatever the service you want to use in the Kubernetes, you will just execute that with a command or with a UI. Internally, API server will interact with the Kubernetes API and will execute the code available in the Kubernetes to perform the operation. That is called API server. Okay, all the above Kubernetes services implemented using Go language. To use these Kubernetes concepts, to use Kubernetes services, we no need to learn Go language. We no need to learn Go language. Okay, Kubernetes developed by using Go language. These all are the topics available in the Kubernetes. I want to deploy my application. I will just execute a command, or I will go to user interface. I will click a button called deploy, or I will go to kubectl. I will execute a command called Kubernetes deploy my application. Then what will happen? Whatever the command I execute, that command will be executed by using kubectl. Kubectl will execute that command in the master node. In the master node, API server will be available. API server will talk to Kubernetes software internally, will perform the operation. So API server is going to act as a mediator between kubectl commands and Kubernetes software. Are you guys able to understand what is API software? To use K8s services, K8s provided API server. When we execute a command, API server will interact with Kubernetes software and it will perform required operation. That's it. You no need to learn the Go language. You just execute a command by using kubectl. Then kubectl is going to talk to API server. API server will talk to underlying Kubernetes software, will perform the operation. Are you guys able to understand what is API server? Are you guys able to understand what is API server? API server will act as communication channel between communication channel between users and Kubernetes components. Can I say it is a mediator between Kubernetes software and kubectl or API users? Between developers and DevOps engineers. Come on, who is going to work with Kubernetes? Sometimes the developers will work with Kubernetes. Sometimes the DevOps engineers are going to work with Kubernetes. I want to deploy my application. I no need to know the Go language. I will just execute a deploy command. Then it is going to interact with the Kubernetes software, will perform the operation. That is called API server. API server will act as a communication channel between developers, DevOps engineers, and Kubernetes components. Are you guys clear? Are you guys clear? Now, next one, what is etcd? Etcd is going to act as a data store in the Kubernetes. Suppose I am asking to deploy my application. I want to tell to Kubernetes software deploy my application. By using kubectl, I will execute a command, deploy my application. That means I'm sending a request. When we send a request to Kubernetes to run our application, API server will receive the request, will store that request data in the data store. That is called etcd. Now I'm going to use the kubectl. I will execute one command, deploy my application. Who is going to receive that request? Directly our application will be deployed? No. We don't know what is the code available in the Kubernetes, that software, right? We are just end user, we are using. When I ask the Kubernetes to deploy my application, that request will go to API server. API server will store the request data in one database in the Kubernetes. What is the database used by the Kubernetes? etcd. What is the database used by the Kubernetes? It is a data store available in Kubernetes. It is a key value pair. It is a key value pair data store in Kubernetes. Okay, it acts as a database for Kubernetes. It acts as database for Kubernetes. Like how many pods? Like how many pods to execute, or how many pods are running, how many nodes are available, how many containers are running. All this information will be stored in etcd. Okay guys, etcd is a database of our Kubernetes. It is going to store the data in the form of key value pair. Okay, when we ask Kubernetes to run our application, when we ask Kubernetes to deploy our application, then API server will receive that request and it will store into etcd database. It will store into etcd. When I ask Kubernetes to run or deploy my application, I want to run my application. I have a Docker image. I want to run my application in the Kubernetes cluster. I will ask the Kubernetes to run my application. Then API server will receive my request, and that API server is going to store the data in the etcd of the Kubernetes. What is etcd of the Kubernetes? Etcd is a data store which is going to maintain a database information. Kubernetes information will be available in the etcd. Okay, next one, what is scheduler? In the master node, there is scheduler topic is available. What is scheduler? Scheduler is used to schedule the execution of pods in the worker nodes. Now I want to run my application. Master node is used to assign the task to the worker nodes. So in the master node, there will be a scheduler. I want to schedule my containers execution in the pods. The pods creation, pods execution will be taken care by scheduler. It will schedule pods which are unscheduled based on etcd database. Pods, it will schedule pods for execution which are unscheduled based on etcd. Etcd will maintain the data. Okay, now how it is going to schedule? It will schedule, scheduler will schedule pods on the nodes with the help of kubelet, not tubelet guys, it is kubelet. Okay, you see here in the worker node kubelet is available. So scheduler, whenever we send a request to run our application to the master node through kubectl, that request will be received by API server. That request information will be stored to etcd. Etcd is a database. Once the database data is stored in the database, scheduler will check, is there any request pending? Scheduler is going to check that. Then scheduler is going to schedule the pods execution on the worker nodes. In order to execute the pods on the worker nodes, this scheduler is going to use a concept called kubelet. Scheduler will schedule the pods on the nodes with the help of kubelet. Okay, what is this kubelet? Kubelet is a worker node component. Understand what this is going to do? Kubelet, scheduler will talk to kubelet to understand or to identify. Scheduler will talk to kubelet to check the resources to run our application. Hey kubelet, you are on the worker node. Do we have the memory? Do you have the space? Do you have the resources to run my pod? Like that, this scheduler will talk to kubelet, will understand the details of the worker node. For every worker node, one kubelet will be available. Kubelet will give the information about the worker node to the scheduler. Based on the information given by the kubelet, scheduler is going to schedule the pods execution on the worker node. So kubelet is a worker node component. Scheduler will talk to this kubelet to check the resources to run our application. Okay, then what is this kubelet? Kubelet is a node agent. It is going to act as a personal assistant for the worker node. Okay guys, so suppose if you go for celebrities, politicians, can you go and directly meet Narendra Modi? Can you go and meet Narendra Modi tomorrow morning directly? No. So if you want to meet Narendra Modi, then what you need to do? First, we need to talk to his PA and we need to take the appointment. So if you ask the PA, tomorrow I want Narendra Modi appointment at 9 o'clock. Can he give directly tomorrow 9 o'clock appointment of Narendra Modi? What he will do? First of all, aap kaun hai? Okay, you are also a celebrity. Okay, then what that assistant will tell? Let me check the dates. Let me check the schedule of Narendra Modi. So he is going to check the dates. Okay, tomorrow already schedule is busy. You can come next Saturday, coming Saturday morning at 10 o'clock. I will give you appointment. So that personal assistant is going to check the availability of that prime minister, and based on the prime minister's schedule, he is going to book our appointment. That means, can I say that PA is acting as an agent of our Prime Minister? Who is going to schedule appointments of the Prime Minister? Yes. Similarly, kubelet is also going to act as a worker node PA, a agent, personal assistant for the worker node. Kubelet is a node agent, runs on each node and it reads containers information and it will check containers are running properly or not. Okay. Kubelet. Kubelet will act as node agent. Kubelet will act as node agent. Got it? Kubelet will ensure that containers are running healthy. Containers are running healthy in the pod. Kubelet will ensure that containers are running healthy in the pod. Kubelet will create the container using runtime. Kubelet will interact with runtime to create a container in the pod. Right? What is runtime? Here we will use Docker runtime to create our containers. So who is going to use the Docker runtime? Who is going to use the Docker runtime? Docker is required because Docker is used to create the containers. Who is going to create that container using Docker? Kubelet. Kubelet is going to act as a agent for the node. Kubelet will make sure pods are created, containers are created, containers are running, memory is available, resources are available or not. When we give a task to the Kubernetes cluster to run our application, API server will receive the request. API server will store the data to the etcd database, that is internal database of the Kubernetes. Then scheduler will check the database. Is there any request pending or the requests are not available for execution? If any request is pending, then scheduler will take that pending request, will talk to Kubelet. Hey Kubelet, I have a request. Do you have memory to run my application? Then Kubelet is going to check the resources available on the worker node and Kubelet will give the information to the scheduler. If the resources are available, then scheduler will schedule the pod execution. Then Kubelet is going to use the Docker runtime, will create the containers in the pod. So that lot of things are going to happen internally in the Kubernetes cluster. Got it? Kubelet will act as a node agent. Kubelet will act as a node agent and Kubelet is going to interact with the container runtime to create a container. Okay, then what is a kube proxy? In the worker node, what is a kube proxy? Kube proxy is available on the worker node. Kubelet is available and kube proxy is also available. What is this kube proxy? What is this kube proxy? Kube proxy acts as a network proxy. Kube proxy acts as network proxy. Right? Kube proxy will maintain network rules on the nodes. Network rules will be available, which network we need to allow, which network we should not allow. That kube proxy will maintain network rules on pods. Are you guys getting my point? Kube proxy will maintain network rules on pods. Network rules are used to allow the traffic or the communication between inside and outside network to our pods. The network rules, whatever the network rules we are going to take by using kube proxy, the network rules allow the network. The network rules allow the network communication, allow the network communication to your pods from inside or outside of your cluster. Now my pods are running. somebody is trying to access my pod, inside or outside. Do we need to allow them or not? It is something like a firewall. It is something like a security groups we have, right, where we do firewall configurations. So similarly, in the Kubernetes cluster, we are going to use kubeproxy to configure those network rules. Which traffic we need to allow to access our pods, which traffic we should not allow to access our pods, that can be configured by using kubeproxy. Are you clear? What is a kubeproxy and what is a kubelet? Kubelet is like an agent on the node. Kubeproxy will provide network rules to allow the access inside or outside of our cluster. Some requests will come inside, some requests will come from outside. So what requests we need to access, that can be managed by using network rules. Those network rules we are going to configure by using kubeproxy. Samjha? What is a kubelet and what is kubeproxy? Are you guys clear? Are you guys clear? Next one. We need to talk about, next thing is controller manager. We need to think about what is controller manager. Okay, controller manager is used to run tasks in the background of our Kubernetes cluster. What is controller manager? Suppose I am asking to run my application, so there will be a deployment controller. Controller manager runs controllers in the background. Deployment I want to do, auto scaling I want to do, replication factor I want to do, rollbacks I want to do, whatever the work that you want to do, that can be done by using controller manager. Okay, controller manager runs controllers in the background. Controller manager runs controllers in the background. It is responsible to run tasks in Kubernetes cluster. Like I want to run my application, that work will be done by controller manager. It performs cluster level operations. It is responsible to run tasks in Kubernetes cluster. Okay, it is going to perform, it performs cluster level operations. It performs cluster level operations, right? We have several controller managers in Kubernetes. We have several controllers in Kubernetes. What are those? Node controller is available, which will manage the nodes. Replication controller is available, which is going to replicate our containers in the pods. Endpoint controller is available. Endpoint controller, it will join the services and pods together. Deployment controller is available. Deployment controller is available to deploy our application. So here there are several controllers are available in our application. There are several controllers are available in the Kubernetes, which is going to run the tasks in the background. For example, I want to deploy my application. Deployment controller will there. I want to increase the replication factor. Replication controller will be available. Master node should connect with the worker node to check the health. Then node controller will be available. So controller manager is responsible to manage controllers of Kubernetes, right? The tasks, Kubernetes cluster tasks will be managed by controller manager. Managed by controller manager. Right? Finally, what is pod? What is pod? What is pod? right? What is a pod in the Kubernetes? Every time we are talking about pod. What is that pod? A pod, a pod is smallest. A pod is the smallest execution unit in Kubernetes. Pod is the smallest execution unit in the Kubernetes. A pod encapsulates. A pod encapsulates one or more applications in the Kubernetes cluster. So we can create multiple containers. We can run them as one unit. So logically, we are going to group the containers. So one logical group of the containers is called as one pod. One logical group. One logical group is called as one pod. Pods are the smallest deployable units of computing that you can create and manage in the Kubernetes. Okay, one pod can contain multiple containers. One pod can contain multiple containers. Are you guys clear with my point? Are you guys clear with my point? What is a pod? One pod is nothing but one logical unit in the Kubernetes, a smallest execution in the Kubernetes, a smallest unit in the Kubernetes. Containers will be grouped. Containers will be grouped into one pod for sharing of the resources. Containers will be grouped. Containers will be grouped as one pod. Containers will be grouped as one pod. Why? In order to increase, the intelligence, of resources sharing. So I want to run multiple containers on the same virtual machine. Multiple containers I want to run on the same virtual machine. Then we are going to group those containers as one pod. Pod is nothing but group of containers. Yes, multiple APIs can be run in multiple containers. Multiple containers, we can group them as one pod and we can run that pod on the worker node. Pod is a smallest execution unit in the Kubernetes. So your application will be wrapped into multiple containers as one pod, and that pod we are going to run on the worker node. Got it, guys? Right? Yeah, here we can go for single container pod, multi-container pods also we can create. Pods that runs a single container, pods can run single container as well as can run multiple containers. One container we can run in the pod, or we can run multiple containers also in the pod. Pod is a smallest execution unit. Smallest execution unit. So here you can check that what is pod in Kubernetes. So what is pod in the Kubernetes? Let's go to official website. Pods are the smallest deployable units of computing that you can create and manage in the Kubernetes. Pod, as in a pod of whales or P-pod, is a group of one or more containers with a shared storage and network resources and a specification for how to run the containers. Pod containers are always co-located and co-scheduled and run in a shared context. It is a logical unit. It is a logical unit. While Kubernetes supports more container runtimes than just Docker, Docker is the most commonly known runtime, and it helps to describe the pods using some technology from the Docker. Right, using the pods, following is one of the example to use the pods. We'll talk about all these things, how to run the applications by using kubectl, workload resource for managing the pods, pods that run a single container, pods that run multiple containers. So what is the main reason to group the containers for resource sharing? What is the main reason for pods with multi containers for resource sharing? On one virtual machine, I want to run multiple containers. Okay, so I want to do the resource sharing for the multiple containers. For that, we are going to use pods. Are you guys clear? Now look at the diagram. Did we understand everything? Master node and worker node. On the master node, we have API server, scheduler, controller manager, etcd. On the worker node, we have kubelet, kubeproxy, Docker runtime, containers, and pods. In order to interact with the control plane, we are having user interface as well as a kubectl. Kubectl is kind of CLI software. We are going to execute the commands. We are going to execute the commands in order to perform the operations on the master node. Okay, when we execute a command by using kubectl, that will talk to API server. API server will act as a mediator between that kubectl and Kubernetes software. When I want to run my application, I will execute a command by using kubectl. Then that will give the request to the API server. API server will talk to underlying Kubernetes software. Whenever a request comes to the API server is going to store the request information in the etcd. etcd is a data store in the Kubernetes, which will act as a Kubernetes database to store the details of the Kubernetes cluster, requests and all. Whenever a request comes, API server will store the request in the etcd. Then scheduler is going to check that. What are the pending tasks are available. Then scheduler is going to assign the task to controller manager. Controller manager is going to schedule them. It is going to execute them, right? So before going to schedule, scheduler will talk to kubelet. What is a kubelet? Kubelet is a worker node agent. Kubelet is going to check the health of the node. Kubelet will check the resources available in the node. Kubelet will make sure pods are running successfully, containers are running successfully. Kubelet will create the containers on the worker nodes using pods with the help of Docker runtime. Docker runtime we are using to create the container. Container is nothing but a runtime of our application. Multiple containers we are going to create. So I want to group my containers to one logical unit for the better management, for the better resource sharing. So that's why we are going to use a pod concept. One pod can contain multiple containers, or one pod can contain only one container. The main reason of going for the pods, so to group them. Now, if you go for a simple example, I am taking two DevOps classes. Why I am taking one class at 7 o'clock? Why I am taking one class at 8:30? Why I am not combining both of them? Can you tell me? I am running two batches for the DevOps in the evening. 7 o'clock one batch is available. 8:30 one batch is available. Why I am not conducting the single DevOps class for both people, both batches? If I combine both, can I manage them? For you people, I'm teaching Kubernetes. Can those people understand the Kubernetes now? Can those people understand the Kubernetes now? To understand the Kubernetes, what is required? Docker is required. To understand the Docker, they need to understand, first of all, Jenkins, GitHub, Tomcat, Sonar, all those tools. So we are running two batches into different slots to manage them properly. For one batch, we are teaching Jenkins. For another batch, we are teaching Kubernetes. I'm not combining them. If I combine, I cannot manage. So similarly, when we are running the multiple containers in the single worker node, it is difficult to manage each and every container. That's why we are going to logically group the containers for management. That's where pod came into picture. Pod is nothing but one logical unit of our containers. So multiple pods we can run on the container so that we can manage those containers easily as a group. Got it? Pod nothing but group of containers. Is it mandatory to run multiple containers in one pod? No. You can run a pod with one container, or you can run a pod with multiple containers, depends upon requirement. Good. Next one, kubeproxy. What is kubeproxy? Kubeproxy will provide network rules who can access our pods within the cluster or outside of the cluster, who can access our pods. That network rules will be managed by kubeproxy. Got it? Are you clear? Are you guys clear with the Kubernetes cluster architecture? Just to understand architecture, it took 1 hour. Now we need to work with this architecture, guys. Now we need to work with this architecture. Now think about it. Just to understand the architecture, we took 1 hour of time. Lot of components are available. Come on. Okay, good. So with this, we understood what is Kubernetes, what are the features of the Kubernetes, and Kubernetes architecture, and how to communicate with the Kubernetes, and architecture components, API server, etcd, scheduler, kubelet, pod, kubeproxy, controller manager, all these things. Good. Now the next step is Kubernetes setup. So shall we do it now or tomorrow? Setting up Kubernetes cluster, it will take half an hour. Or else I will give the document for you. Can you guys try setting up the Kubernetes cluster? Can you guys set up the Kubernetes cluster for me? Kubernetes installation. I prepared one document. I will give you Kubernetes installation process. Guys, it is lengthy. It is little lengthy process. So many commands you need to execute to set up this Kubernetes cluster. Okay. Now, in order to work with the Kubernetes cluster, we need to do some installations. Okay, guys. Kubernetes cluster setup. We can set up the, we can work with the Kubernetes cluster in 2 ways. Are you guys getting my point? How many ways we can work with Kubernetes cluster? There are 2 ways we can work with Kubernetes cluster. There are multiple ways to set up Kubernetes cluster. There are multiple ways to set up Kubernetes cluster. One is, first approach is self-managed K8s cluster, and second one is provider managed Kubernetes cluster. provider managed or managed Kubernetes cluster. Provider managed K8s cluster. So if you want to work with Kubernetes to orchestrate your containers, we can use this Kubernetes in multiple ways. One is self-managed Kubernetes cluster, and the second one is provider managed Kubernetes cluster. As part of this course, I'm going to show you both approaches. Self-managed Kubernetes cluster is nothing but we have to set up manually everything. Like this architecture, we have to set up. If you go for provider managed Kubernetes cluster, AWS having one service called EKS, Elastic Kubernetes cluster. You no need to do anything. AWS will provide the cluster for you. If you go for GCP, GCP will provide the cluster for you. Okay, guys. Now, self-managed cluster means we have to set up the cluster of Kubernetes to run our applications. Okay. To create self-managed cluster, we have two options. To create self-managed cluster, we have two options. One is Minikube. Second one is Kubedium. One is Minikube. Second one is Kubedium. Minikube is nothing but single node Kubernetes cluster. That means only one node. Single node Kubernetes cluster. It is used just for practice purpose, not in the real time. For production, we don't use it. When the new people are trying to learn the Kubernetes, so setting up the multi-node cluster is a little difficult. So that's why Kubernetes software people provided a concept called a Minikube. By using Minikube, you can set up single node Kubernetes cluster. But in the real time, we need multi-node cluster. For multi-node clusters, we are going to use Kubedium. Kubedium is used to set up multi-node Kubernetes cluster. Self-managed cluster means we have to set up the cluster. We are going to set up virtual machines. We are going to install the Docker. We are going to install the Kubernetes. We are going to install kubectl. We are going to execute the commands. We are going to deploy the applications. All these things we need to do manually. If we are doing the things manually, then that is called as self-managed Kubernetes cluster. That means we are setting up our infrastructure. We are taking virtual machines and we are going to install Docker software. We are going to install Kubernetes software. We are going to manage everything on our own. That is called self-managed Kubernetes cluster. Array, I don't want to go for this. Why should I spend my time to set up all these softwares and manage? Let's go for provider managed cluster. What is the meaning of managed cluster? Provider managed cluster means cloud providers. Managed cluster means provider managed Kubernetes cluster. Provider managed cluster means we will use Kubernetes cluster which is configured by provider, which is configured by someone. AWS provided one cluster, EKS, Elastic Kubernetes Service. If you want to run the Kubernetes cluster in the AWS, Elastic Kubernetes service available. It is given by AWS Cloud. In the AWS Cloud, if you go to our AWS account, we are using AWS accounts, right? In the AWS account, we can go and use EKS, Elastic Kubernetes Service. So that means they will manage the cluster for you. You no need to set up Elastic Kubernetes Service. The most trusted way to start, run, and scale your Kubernetes. So if you want to manage your applications by using Kubernetes cluster, then you can set up that by using EKS. You see, fully managed Kubernetes control plane. You see what is a control plane? Control plane is nothing but master nodes. Amazon EKS is a managed service that makes it easy for you to use Kubernetes on AWS without needing to install and operate your own Kubernetes control plane. Instead of you are creating that, AWS will create it. You can just use it, but it is not free. It is paid. It is not free. It is paid. Okay, so now if you go for EKS in the AWS, Elastic Kubernetes service is available. Suppose if you go for Azure, AKS is available. Azure Kubernetes service, which is given by Microsoft in the Azure cloud. Some projects are using Azure cloud. In the Azure cloud also, they can manage the Kubernetes cluster by using AKS. Okay. Some people are going for Google Cloud, that is GKE, Google Kubernetes Engine. Google Kubernetes Engine. The Kubernetes developed by Google only, right? So Google Cloud, GCP is available. In the GCP, there is AKS service, GKE service. In order to manage the Kubernetes cluster, Google Cloud Platform, GCP, Google Cloud Platform, GKE is available. IBM Cloud is available, IKE, IBM Kubernetes Engine. IBM like AWS Cloud, Azure Cloud, GCP Cloud, IBM Cloud is also available. That is IBM Kubernetes Engine. IBM Kubernetes Engine, which is IBM Cloud. So these all are managed Kubernetes clusters. So you no need to do the setup. They will take care of that setup. If you go for them, you have to pay the money because they are providing the setup for you. You need to pay the money for using their setup infrastructure. They are going to provide you. If you don't want to pay that money, then you need to set up your own cluster. That is called self-managed cluster. We have to set up the cluster of Kubernetes to run. Self-managed cluster means we have to set up Kubernetes cluster to run our applications. We have to set up the Kubernetes cluster on our own. Lot of commands to install. To create self-managed cluster, we have two options. One is Minikube, another one is Kubedium. If you go for Minikube, single node cluster you can set up. If you go for Kubedium, multi-node cluster you can set up. Multiple worker nodes I can take by using Kubedium. If you go for Minikube, single worker node will be available for you. Single node cluster with Minikube, and Kubedium means multi-node cluster we are going to set up. So Minikube they have given only for practice purpose. So see here, what is Minikube in the Kubernetes cluster? What is Minikube in Kubernetes? Minikube in the Kubernetes. Hello Minikube. You can also follow the tutorial if you have installed Minikube locally before you can create a Minikube. What is this Minikube? Directly they have given hello Minikube. This tutorial will show you how to create this Minikube, how to set up this Minikube. What is Minikube? What is Minikube? Using Minikube basic tutorial. Okay. Kubernetes is a great for large scale application, providing security, scalability, portability that most of organizations can recognize. For large scale application, Kubernetes is usually deployed through a cloud providers like them. Options. Minikube takes the core of the component functions of Kubernetes such as networking, dashboard, security, easier to use while allowing to move beyond the limits when required. There are add-ons available for this. Setting up Minikube. So it is used to set up a single node cluster. Similarities between the Kubernetes and Minikube. Yeah. So Minikube is one of the software that they are provided, guys. It is easy to set up the Kubernetes cluster. The beginners who are starting with Kubernetes, so easily they can set up the Kubernetes cluster by the help of Minikube. But for the production grade applications, we are going to set up multi-node cluster. To set up the multi-node cluster, we are going to use KubeADM. So this is self-managed cluster options. So if you don't want to set up the cluster, if your client is ready to pay the money for the infrastructure of the Kubernetes, then you can go for provider managed Kubernetes cluster. Provider managed Kubernetes cluster means infrastructure already created by them. You just need to run your application on the cluster. AWS provided EKS, Azure provided AKS, GCP provided GKE, IBM Cloud provided IKE. So these are provider managed clusters, and we can go for self-managed cluster also. Good. So I'm going to show you in this course how to work with self-managed cluster as well as how to work with EKS, because we started this DevOps with AWS, right? So I'm going to show you how to work with Kubernetes with self-managed cluster as well as with AWS Cloud EKS. Good. Your beautiful notes is getting prepared. I will share it, guys. You guys can read these notes. I'm doing multitasking. I'm teaching at the same time I am writing. So these notes I can use for upcoming batches. I will prepare this as one PDF and I will share in the upcoming batches. I no need to type all these things every day. It is killing our time. So PPTs are better, writing the notes is better in the class. Guys, what is your idea? PPT is better, writing the notes is better. Writing the notes is better, huh? Oh, you like this approach, huh? Some people are saying PPT, this is good. Mixed answers. Okay, fine. But if I go with PPT, it will be like a news reading. If you go for PPT, it will be like a news reading. Nothing will be there. If I am writing, then it would be good. Yeah. Sid, Docker Compose topic. Docker Compose is completed, sir. In the Docker Compose, I want to show you Spring Boot application with the volume that was pending. So I will cover that by integrating with this Kubernetes. Okay. Volumes I did not used in the Spring Boot application that was pending. That will be covered when I am deploying that Docker container to Kubernetes cluster. I will show you that. So it's not like covered. So integration part about that I have not shown you. Okay, good. Registry, ECR, registry, Akhil, yes. Nexus repository and ECR both I will show you. Yeah, first let me complete the Kubernetes. So whatever the pending is there so that we can focus on that. Nexus repository I have to explain. Monitoring tools I have to explain, like Prometheus and Grafana, some ELK stack tools, that then we will implement this Docker Kubernetes for a project. I will take a Spring Boot application, we will do that, and the Python application I will take and I will do it. Don't worry. Okay, good. ECR registry also, man. When I'm talking about Docker images storing, ECR also you can use to store your images. We are storing images in the Docker Hub. If you want in the cloud, you can store in the ECR registry. I will show you that as well. Guys, learning topics are never ending process. So you guys need to do some self-learning also. For everything, you should not dependent on me. Some things you need to try, you need to Google, you need to try on your own. If we are keep on running, this DevOps course will run for next 1 year also. There is no end. There is no end for this. So you need to have that maturity. Nobody knows everything. We have to research and we have to learn that. Okay. Good. So are you clear with this? What is Kubernetes and Kubernetes features? and Kubernetes architecture and components of the Kubernetes cluster and cluster setup introduction. So how many ways we can set up the cluster? Two ways. One is a self-managed, another one is provider managed things concept. Yes, good. Namespaces and all will come in the tomorrow session. Kubernetes namespaces, Kubernetes deployments, Kubernetes services, Kubernetes RBACs, Helm charts, everything will come. Kubernetes workflow. Yes, once I take the application, I will tell you what is the workflow. Still, we are in the installation process, right? Once we are done with the installation, when I deploy my first application, then I can tell you the workflow of the Kubernetes. Okay, next one, guys. So before coming to tomorrow session, I want you people to do this cluster setup because cluster setup is a lengthy process. Lot of commands we need to execute. Okay, don't uninstall this Kubernetes, guys. I just want you to do the setup. Kubernetes cluster setup. Create one security group with the protocol as all traffic as a port range 0265535. So when we are going to set up a Kubernetes cluster in the AWS, so first create one security group, guys. So we are going to use that for Kubernetes cluster. Go to security groups, create one security group, create one security group. Security group name we are going to use as my K8SSG. My K8SSG. This is the security group. Inbound rules. So I'm going to enable SSH with the 22 custom anywhere. And there are some protocols we need to enable, guys. There are multiple protocols we need to enable. For time being, I'm going to enable all traffic protocols here. I'm going to enable all traffic protocols. Okay, so why we need to go for all traffics? Are earlier we used HTTP 80, RDP 3389, right? Like that, several protocols we used. But currently for Kubernetes cluster, we are going to use all traffic. I will tell you the reason also, because there are 4 to 5, 6 ports we need to enable to work with the Kubernetes cluster. So I will explain the port numbers slowly. So first, you create one security group with all traffic in the inbound rules. Okay, then create security group. So when we create this security group with a name, where is that name I used? My Kubernetes security group. This I will use while I'm working with the Kubernetes cluster. My K8S security group, I am going to create it. Then I'm going to take 3 Ubuntu servers using above created security group. One Ubuntu machine I will use as master node. For the master node, we need to take T2 medium instance because it will give 4 GB space, and 2 worker nodes I'm going to take like this architecture. So whatever we have seen in this architecture, one master machine I'm going to take, 2 worker machines I'm going to take. This master machine I'm going to take as T2 medium instance because we will get 4 GB RAM. Worker nodes I will take T2 micro only. Once these 3 instances created by using this security group, you need to execute several commands. First, we need to install the Docker. Then we need to install Kubernetes. Okay. Once we have done all this installation process, so whatever this is step 1, step 2 is available, these step 1, step 2 commands, installing the Docker, installing the Kubernetes, you need to do in all the 3 machines. Master and slave common commands execution start. So whatever the commands I have given here, master slave common commands execution start. So step 1 commands, step 2 all these commands you need to execute. This setting these host names and all, you can ignore this for time being. All these commands you need to execute in all the 3 machines. Master slave common commands execution start. So step 1, step 2 commands you need to execute. Once it is done, then in the master node, we need to execute few commands. So step 3, running and deploying the Kubernetes, those commands we need to do only in the master machine. We need to do only in the master machine. Do that setup, guys. Deploying application to the Kubernetes cluster, uninstalling the Kubernetes, that we will discuss in the next part. Uninstalling Kubernetes, you don't need to do this, guys. You just ignore it. Deploying the application also, you don't need to do it. You just do step 1, step 2, step 3. Step 1, step 2, you need to do in all the 3 instances. Step 3, you need to do only in the master machine. Which node you are taking as a master, only in that you need to do that process. So lot of commands that you need to execute. I will share this document. Can you guys come up with cluster setup before coming to tomorrow session? Can you make this cluster setup? I have given everything in the notes step by step. Which commands are common for all the 3? Which commands are only for master? Only master node commands execution start. After doing all the common commands execution in all the 3 machines, these step 3 commands you need to execute only in the master machine. Tomorrow, I will tell you what is the purpose of all these commands and all. Okay. So don't worry about the installation commands and all, guys, because these installations we are not going to do every day in the project. It is one-time setup. Yes, you don't need to butify all these commands. You can take these commands from the internet. Official website of the Kubernetes also is giving this. Okay, guys, fine. Thank you. So with this, I'm stopping for today. I will upload these 2 documents now. One is introduction part of the Kubernetes and second one is Kubernetes cluster setup. Please do it before coming to tomorrow's session. Thank you, guys. Good night.